continue with the very first question. Student observe different stars from the Earth. Give two reasons why some stars appear brighter than the others. What could be the reasons? We discussed in terms of luminosity and
Intensity or what?
Intensity.
intensity. So
Intensity
give
is
two
correct.
reasons why some stars. So we could say that the first reason it could be closer to us, and secondly, brighter star could have a greater luminosity. Then they have a question: what is meant by standard candle? Standard candle का meaning क्या होता है? Whose luminosity is known.
Known.
देन उन्होंने ये वही एग्जांपल जो हमने की थी वही वाली आई हुई है जो बुक में एग्जांपल थी. उन्होंने कहा है शो दैट द स्पीड ऑफ द स्टार रिलेटिव टू द अर्थ इज 2.1. सो फॉर्मूला क्या यूज करेंगे हम लोग? हमारे पास 3 वेज में वो फॉर्मूला गिवन था. डेल्टा लेमडा ओवर लेमडा प्रोपोर्शनल टू डेल्टा एफ ओवर एफ प्रोपोर्शनल टू वी ओवर सी. सो हम लोग किसको यूज करेंगे? ये वाला रिलेशन यूज करेंगे. डेल्टा लेमडा इन दोनों को माइनस करके फाइंड आउट करेंगे. 660 माइनस 656 क्या आंसर आएगा? I don't have my calculator, so anyhow, just look it out. 656.3 divided by original wavelength कितनी है हमारे पास? 656. Observed wavelength in laboratory would be considered as original wavelength. 0.3 equals to speed over speed of light in 10 raised to power 8. Rearranging it would give us the value of C. RIA relation 2.1 into 10 raised to power 6 meters per second.
ये याद है.
2.1
हाँ यही है.
raised to power 6. Second part में उसने calculate the distance. Hubble's constant किसके इक्वल होता है? We just discuss h equals to v over d. v हमने अभी अभी calculate किया. Rearrange करेंगे. d would be equals to v over h naught. v की value 2.1 into 10 raised to power 6 and h naught is given as 2.3 into 10 raised to power minus 18. Get the value?
9.1 times 10 power 23.
23 meters. Moving on to the next part, we have state and explain what could be, what can be concluded about the universe based on these changes in the observed wavelength. We know the answer. हमने अभी भी discuss किया था कि universe is continuously expanding. The wavelength has increased and moved to the redshift. So as the redshift explain us that the system is receding from us. So from this, we'll observe that the wavelength has increased, shifted to red. Star within the galaxy is moving away from us. So universe is expanding. State Hubble's law, identify the symbols that we use. क्या होता है Hubble's law? H is equals to V over D. And Hubble's law का main definition क्या था? That the speed is proportional to the distance. So h naught equals to v over d. इसको फर्दर ऑन अगर हमने लिखना हो तो स्पीड ऑफ रिसेशन लिख सकते हैं. कॉज ये फर्दर अवे जाते हुए की स्पीड है ना. स्पीड ऑफ रिसेशन ओवर डिस्टेंस of the galaxy from the observer. Oh my pen. Distance of the galaxy from observer. Next part is we have to calculate the radiation flux density. Luminosity is given, the distance is given. What was the formula? Reep.
Is equal to 4 pi L over D square. F is equal to.
Luminosity is 3.8. Calculators ready करो जल्दी से 3.8 raised to power 31 over 4 into pi into 1.8 raised to power 24 square.
9.3 times 10 power minus 19.
Unit is already given, so we don't have to write it down. The next part is, so starting with question number 2, part C, they've asked us the stars and be in a distant galaxy. A spectral line, the light from this galaxy is known to have a wavelength of 486 nanometer. The spectral lines in the spectral line in the light from the galaxy observed on Earth has a wavelength of 492. This vector. And explain why the wavelength of the Earth is different from the wavelength but the galaxy. So we already have discussed this, that whenever we have a bigger wavelength, that means that galaxy is moving away from us. Or we could also say that it's continuously expanding, so the universe is continuously expanding. Or we can also say that the
Doppler effect
Doppler's effect justifies increase in wavelength due to relative motion. Okay. Then they have asked us to find out Hubble's law. We know that Hubble's law is given by the formula H is equals to V over D. So first of all, we need to find out this V factor. For that, we're going to take help from Doppler's effect relationship, which is V over C. Change in wavelength find out करेंगे सबसे पहले, that would be 492 minus 486. This is the increased wavelength. This is the original wavelength. So we'll divide this with the original wavelength, which is 486 times C cross multiply 3 into 10 raised to power 8. So the value of V would come out to be
3.7 times 10 power 6.
10 power 6 meters per second. So we have the Hubble's law now. What do we have in the next part? Okay. It's define mass effect. And why do we have this question? Okay. The next portion was related to that. So the first of all, they have asked us the mass defect. How do we define mass defect? It's the difference between the mass of the nucleus and the total mass of nucleon. That is when proton and neutron added and the mass of nucleus itself. So the difference between these two is the mass defect. They have asked us to find the nucleophile process in a particular star is described by I have to go. State the name of the particle X. So in order to when we balance out the equation, we know that we have seen these equations. So there would be 1 plus 1 is 2, 3 plus 2 is 5. So if 4 is here, it must be neutron because neutron has a mass of 1 and a charge of 0. So that would be neutron. Then in the next part, they said they show that the energy released when one nucleus is formed in this fusion reaction is 2.8. What we'll do is we'll use that E is equals to delta M C square. First, we need to find out the mass defect. For that, we need to add and then subtract it from that. किन दो को हम लोग ऐड करेंगे? हम लोग इन दोनों को ऐड करेंगे और we'll subtract it from there. Find out what is the mass value. 0.030377 minus 0.002388 plus 0.009105. ये तो हम ब्रैकेट में प्लेस कर देंगे cause that is the mass of nucleons together and mass of nucleus. What is the value of m coming out? And it's an unified system. So we might multiply it with the 1.6 into 10 per 27 in the next part to get the value. Anyhow, what's the value coming here? The value of m.
0.01884.
8884 Let's just convert it into kilograms right here. Multiply it with 1.67 into 10 raised to power 27 minus 27 kilograms. So sorry. So that we could directly put it in this equation without wasting any more time.
3.15 into 10 raised to power minus 29.
Can you say it again?
3.15 into 10 raised to power minus 29.
Minus 29 kilograms. Let's put this in this equation now. 3.15 into 10 raised to power minus 29 into c square, which is 3 into 10 raised to power 8 square. So E would come in joules. Do they have asked us? No, उन्हें joules में लिखा हुआ. We do not need to divide it further.
And we are at 2.83 into 10 raised to minus 12.
Sorry?
2.83 into 10 raised to minus 12.
2.83 into 10 raised to minus 12. So round off करके हम इसको will write it as 2.83 into 10 raised to minus 12. Sorry, not 3 here. Joules. अगर इलेक्ट्रॉन वोल्ट में होता what would we do? अगर इलेक्ट्रॉन वोल्ट में लिखा हुआ होता
Divide by 1.6 times 10 power minus 19.
13 मेगा इलेक्ट्रॉन वोल्ट से
19,
कन्वर्ट
19.
करते हैं. Yeah.
90 क्या था?
Mega, okay.
Minus 13.
जी.
Okay, next part they have asked us the star in the has a radius of this. The luminosity of the vector is this. Okay. R is given as this. Luminosity is given all the energy, the mass per unit time by the fusion process. So we have mass per unit. First of all, तो हम power per unit time find out करेंगे. Previously we got joules, which was 2.8 raised per minus 12. So number of atoms per unit time के लिए सबसे पहले हम लोग number of atoms के लिए will divide 1.4 into 10 raised to power 28 divided by 2.8 into 10 raised to power minus 12. What are we getting? We'll use a little bit of chemistry into that as well, because number of atoms find out करने.
5 times 10 power 39.
5 times 10 power 39.
जी.
Okay. And mass of one atom find out करेंगे सबसे पहले. Number of atoms per unit time हो गया हमारे पास, which is 5 into 10 raised to power 3 per second. Because watts is basically joules per second. Okay. divided by joules. Joules will cancel out, that the unit would be 1/2. So mass of, how would we use the chemistry into it? We know that we have four, the mass is 4. The mass of one proton or charge is 1.6 in raised per minus 27 divided by Avogadro's number, raised per 23.
Wait, so dividing power by energy gives number of atoms per unit time?
Yes.
Okay.
Because atom itself does not have any unit into that, so we'll have number of atoms per unit time. Mass of one atom we need to find out first. Did we get this part? All of you? 4 into 1.6 into raised to minus 27 and then divided with Avogadro's number in order to find out the number of atoms.
Yes, 1.06
Sorry, mass
times
of
10
one
power
atom.
minus 4.
This would give us the mass of one atom, which is, can you repeat?
1.06 times 10 power minus 4.
4 into 1.6 into raised by minus 27 divided by 6.02 into raised by 23. I accidentally write minus 23.
Okay. 1.06 times 10 power minus 50.
Yes.
1.06. No, minus 50.
Minus 50. Hold on. Let me clear this out. Are you getting the same answer?
J.
1.06 into raised per minus 50. Okay. Now mass per unit time find out करना, so we'll multiply this with this. So that would be 1.06 into 10 raised per minus 50 times 5 into 10 raised to power 39. We'll get
5.3 times 10 power minus 11.
this.
ये क्यों किया है?
Minus
5 times 10 power 39.
That was mass of one atom per unit time. That was the number of atoms per unit time. और हमें mass per unit time find out करना था. तो हम दोनों को multiply
Divide नहीं
कर दें.
करना.
No, mass, because this already has a unit per second and this has a unit of kilograms. So kilograms per second. See,
Oh, okay.
if I'll divide this with this, I'll get the unit of kilogram into second. The mass per unit time came out to be 5.3 into raised per minus 11. For the next part, we need, they have asked us to find out the surface temperature of the star. So what data do we have? We have luminosity, we have the value of R, and we know the value of Stephen constant. So let's just put the value in the equation and find out the answer. So L equals to 4 pi
4 pi Stephen constant.
Stephen's constant
T4.
into R square into T4. So they have asked us to find out this. So T4 would be equals to L over 4 pi into Stephen constant into R square. L value is 1 point. What was value of L? Okay, I could see it now. It's 1.4 into 10 raised to power 28 divided by 4 into pi into Stephen's constant has a value of 2.3 into 10 raised to power 9. Sorry, 5.67 raised to power 9. It always slips out of my mind. It's 5.67 into 10 raised to power minus 8 into r square, which is 2.3 into 10 raised to power 9 square. Again, r is this, luminosity is this, and rest of the things are constant. So we'll get T4 equals to, we also have to take the fourth root of this. First, let's just get the answer of that and then we'll take the fourth root of it. 1.4 into 10 raised to power 28 divided by 4 pi into 5.67 into 10 raised to power minus 8 into 2.3 into 10 raised to power 9 square.
3.7 times 10 power 15.
Sorry, 0.7 times 10 power 15.
3.7.
3.7. Okay, and take the fourth root of it now.
7.8 into 10 raised to power 3.
7.8 raised to power 3, or we could write it as 7800 Kelvin. Okay, that's the end of this question. Moving on to the next one. They have asked us, state the Hubble's and identify any symbols that you use. Hubble's law is defined as, it tells us the velocity of the, or the speed of the galaxy is proportional to the distance of the galaxy, and Hubble's law is given as h equals to v over t. And just for the revision, that this gives us the speed of recession, and this is the distance of the galaxy. Galaxy from observer. Okay, now we need to find out radiant flux density, which is given as F equals to L over 4 pi r square or d square. The choice is yours. So we have luminosity, we have distance. We'll just simply put it into the formula and we'll get 3.8 into 10 raised to power 31 divided by 4 pi into 1.8 into 10 raised to power 24. What do we get?
9.3 into 10 raised to the power minus 19.
Moving on to the next part, we have ये तो क्वेश्चन रिपीट नहीं हो गया?
एक क्वेश्चन
हाँ,
होगा
ये
तो
repeat है.
Same
We
है
have
वो।
done this. We have done this question. Let's move to question number 5. They have asked us to define luminosity of a star. Luminosity को कैसे define करते हैं? Total power emitted.
by the star.
Total power emitted per unit time. Radiant flux density, we have luminosity is a distance, and luminosity, we'll put it in the formula, which is 8.1, sorry, 9.86 into 10 raised to power 27 over 4 pi into 8.14 into 10 raised to power 16. What was the answer for this one?
1.18 into 10 raised to power minus 7.
1.18 into 10 raised to power
minus 7.
-7
जी.
जी।
watts per meter. Next part में उन्होंने determine the radius of the star find out करने को बोला हुआ है, तो हम इसमें वही Stephen's वाला formula use करेंगे,
What
which is
what per meter?
नहीं होगा square.
L equals to 4 pi sigma r square into T4. Do we have the temperature? Yes, we have the temperature. Ari, what are you saying?
Watt per meter square नहीं होगा.
वही. So we need to find out R. Let's rearrange. R would be equals to under root L over 4 pi into T power 4. Value of L is given as 9.8 into 10 raised to power 27 over 4 pi into T power 4, which is 9830, and square root. What is the answer to this part?
2.9 into 10 raised by 5.
Sorry?
1.2 times 10 power 23.
Oh, we missed the Stephen constant. Sorry.
Volts में constant लगा.
हाँ, Stephen constant रह गया इसमें put करने वाला, which was 5.8, sorry, 5.67 into 10 raised to power 8. Let me calculate it at my end as well. It's square root, which is then
तो -8 आ
luminosity
गया. -8 होगा
point
constant.
luminosity is 9.86 power 27 over 4 times pi times 5.67 exponent minus 8 into 9830 power 4. I'm getting 1.21 into 10 raised to power 9.
सही
Yeah,
same
that's
है.
fine.
Actually, I'm getting 12174046661, which is rounded off to scientific 3, 3, and 3. 1.2 into 10 raised to power 9 meters. For the next part, we have explain how the surface temperature of a distant star may be determined from the wavelength spectrum of WO. For that, we know we have Wien's displacement law, and the product of wavelength and temperature is equals to constant. So we can put that in the, we can define it on that basis. We can find out the wavelength of peak intensity from spectrum of the star, because हम लोगों ने जो टेबल ड्रॉ किया था उसमें यूं था. सो जो मैक्सिमम इंटेंसिटी थी उसके अगेंस्ट जो उसकी वेवलेंथ होती है दैट इज मैक्सिमम, वो हम इंटेंसिटी फ्रॉम द स्पेक्ट्रम ग्राफ इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम से हम उसकी वो वैल्यू फाइंड आउट करते हैं. Then uses Wien's displacement law, which is lambda maximum into temperature equals to constant. So this has a factor of 2.9 something, and lambda we have found out, so we can find the temperature from there. Don't worry, you'll get the values of all these constant in your data sheet. Then we have explain the spectrum of explain how the emission spectrum provides evidence for the existence of discrete level of energy in hydrogen atom. We could go for certain points. Number one would be energy correspond to certain frequency only, that we have studied in photoelectric effect. Energy of photon has a corresponding wavelength. Next point क्या होगा इसका? We could say that change in electron energy emits only one photon. Because whenever an electron comes to its ground state, it emits only one photon. So that also justifies that point. And discrete energy changes.
कंटिन्यूस नहीं होता, डिस्क्रीट होता है.
Yes, discrete energy changes also implies that discrete energy levels. For the next part, we have show that the energy level of X is 1.5 electron volt. We have done these questions so many times. What is the formula? E1 minus
HC.
E2 is equals to HC over lambda or
HC
HF.
over
The choice is yours. So E1, we don't know what that is basically X. Let's write X minus ground state, which is minus 3.400 equals to H, which is 6.63 into 10 raised to power minus 34 times C, which is 3 into 10 raised to power 8 divided by the wavelength. And electron voltage, so we'll also divide it with 658 into 10 raised to power minus 9. Shortest wavelength लेंगे हम लोग. How do we know? ये हमने previously we already have discussed in the hydrogen spectrum worksheet. How do we know कि हमने ये wavelength लेनी है? Because this is the smallest change. So इसकी wavelength सबसे smaller आएगी than the rest of it. सबसे bigger change जिसमें आएगा वो उतना ही ज्यादा ground और versus उस level में change होगा. Do I need to explain that part again?
No.
Okay.
Wait, so for the biggest change, you take smallest wavelength, right?
No, this is this is only up to this level, na. So the bigger wavelength would be from here. From the rest of it, we'll get smaller. What will say? Okay, the smallest value you could say will, because the smallest value would show the biggest wavelength, na.
Okay.
I might not be using the right vocabulary, but I hope you're getting my point.
Yeah.
Okay. What is 6.16 raised per minus 34 into 3 into 8 divided by 658 into raised per minus 9 into 1.6 into raised per minus 19?
आंसर होगा.
Do we need to use? So here from this diagram, we could clearly see, oh, where is the diagram? Here. From this diagram, we could see the energy difference, the wavelength that this must be showing of from the ground state to the first energy. Because in the diagram, they have showed us that. Let me take you, circle this out and take you to that part as well. See, we could see this difference of wavelength here and the gap C. Focus on the gap, and here it's similar, pretty much the similar. So we know the formula is we just discussed, which is E1 minus E2 equals HC over lambda. So it was equals to 6.63 into 10 raised to minus 34 times 3 into 10 raised to power 8 over lambda, which was 658 nanometer, nano for 10 raised to power 9. And we also need to divide it with 1.6 into 10 raised to power minus 19 in order to give our answer into electron volt. And this when moved here plus E2, which is 3.400. What was the answer to X? Sorry, energy level. Yeah, which is X basically. Okay, sorry. It's minus minus would be here. We'll also get minus. Because this minus into minus energy level will become positive and we'll take it on the other side, it will become negative again. What is the value of X?
वो शो करनी चाहिए फिर वो -1.51
Is it 1.5? आ रहा है after this calculation?
yes -1.51 electron
जी
Okay. In the next part, they have asked us to find out. No, it's a theory part. State the name of the phenomenon that gives rise to a change in wavelength. What do we call it?
redshift
Red.
Redshift.
shift
And state what this phenomena shows about the motion of the body. That it's
Universe is
moving.
expanding.
No, it's moving away from us. Yes, expanding. We could also go for that term. And then use one of the lines in figure 9.1 and the corresponding lines in 9.3 to determine the speed of the galaxy relative to the observer. So we'll use the formula delta lambda over lambda is equals to C over V. We have to compare these two wavelengths. 686 we have here. Uh, 658. Let me, if you could see both at the same time. No, बहुत ही छोटा करना पड़ेगा. Anyhow, we have two values. Obviously, 658 would be our original wavelength. So 686 minus 658 over 658 equals to sorry, V over C. I accidentally wrote C over V. V, and I'll just multiply it here. 3 into 10 raised to power 8. What was the answer?
1.3 times 10 power 7.
1 point
3 times 10 power 7.
meters per second. In the next part, they have asked us to find out Hubble's law, which is the formula for the Hubble's law is H is equals to V over D. So H equals to V over D. We just found V, which is 1.3 into 10 raised to the power 7, and D is 5.7 into 10 raised to the power 24. What did we get? Actual value is 2.3 into 10 raised to the power minus 18 per second here. Did we get the same answer after this?
Yeah.
जी
Okay, moving on to the next part. What is meant by the luminosity? I think so this question is repeated again.
Yeah.
आंसर में लीव
Yeah, it's a repeat. A star has a luminosity that is known to be 4.8 into this, and radiant flux density is given also. We know that the formula that we need to use for this is F equals to L over 4 pi D square. We need to find D. So this would be L over 4 pi into F. They have given us whole values. They have given us radiant flux density value as well as this one. So putting this into the factor, we got L is 4.8 into 10 to the power 29 over 4 pi into 2.6
Square.
into nano लिखा हुआ है 10 raised to power 9 minus 9 sorry nano see
Yeah.
nanowatts per meter square. What is the answer?
स्क्वायर भी करना है 3.6 times 10 power 19.
Square root लेना है. We need to take the square root.
Don't we square the distance?
हाँ, so
Oh,
d
but we're
d
finding
find out करना है ना. So d has d का square से वो cancel out होके square root. I have put the square root already. मैंने simplify equation कर दिया था पहले से.
Oh, yeah, I wrote it wrong.
Ali, what do you have?
No, answer to say it 3.6 times 10 power 19, I think. Just my working confused me.
3.8 into 10 raised by 18. No.
This is the right answer. Next part में they have asked us to find out. Okay, that was a question that Arham asked me yesterday, right?
Yeah.
We basically need to use the ratio formula for that. We know that the maximum is proportional to 1 over t. So हमें basically वही करना था. Ali, what did you get as? 5800
6,700.
over 500. Sorry, 5800 surface temperature. The sun has a surface temperature of 5800. The maximum wavelength for which the maximum deformation occur is 500 equals to 500. X is to be found out और इसकी जो वैल्यू है 430 नैनोमीटर है. So हमने डिवाइड कर दिया this wavelength into टेम्परेचर वाले फैक्टर को आपस में. Or you could also write it like this and you could rearrange it. The choice is yours. 5800 into 500 nanometer equals to we do not know the temperature into 430. The choice is yours. I just showed you that you could use like this. So 5800 into 500 over 430. Because nanometer would be cancelled with the nanometer, so do not need to write that unit. What temperature do we got? What value of temperature did we got?
6,700.
6,700. As per my calculator, it's giving me 6740 Kelvin, which could be rounded off to 6,700. And then they have asked us to find the radius of the star. For that, we are going to use F equals to no. We will go for luminosity. We do not have that data available. L equals to 4 pi sigma r square into T4. R हमें calculate करना है. Temperature we just found out. Luminosity हमें given थी previous part में, which was 4.8 into 10 to the power 29 over 4 pi. Stefan constant is 5.67 into 10 to the power minus 8 times 6,700 power 4 का whole under root. Answer please.
1.8 times 10 power 10.
Meters. Let me rearrange for Arib as well. That it's 4 pi sigma into T4 is equals to R square and then taking square root on both sides. Okay, that was the last.